This is the Technology Project Mathematical Modeling. Our problem was you are on an island 2 miles from the nearest point P on a straight shoreline. 6 miles down the shoreline from point P is a restaurant at point R. To reach the restaurant, you must first row from the island to point Q, averaging 4 miles per hour. You will then jog the remaining distance to point R, averaging 6 miles per hour. In Part A, we were assigned to create a model to reach point R and a function of the distance between point R and to the point row to Q. In Part B, we were assigned to find the minimum time it will take you to reach the restaurant and how far you need to row from the restaurant. Part C asked how long it would take to jog only half a mile. We defined our independent variable x as distance and our dependent variable t as time. Our diagram demonstrates a visual of the word problem, with point P being 2 miles away from the island and point P being 6 miles away from point R. We designated line segment point PQ as a distance of 6 minus x miles and a line segment QR as a distance of x miles away. Through the hypotenuse formula, we found that the path from the island to point Q to be squared root of x squared minus 12x plus 40. From the hypotenuse formula of a squared plus b squared equals c squared, we manipulated it by plugging in 2 miles as a plus 6 minus x as b, squaring both and setting it equal to the distance between the island and Q as c squared. From that, we got 4 plus 36 minus 12x plus x squared, which equals c squared. From that, we got x squared minus 12x plus 40 equals c squared. And then finally, the square root of x squared minus 12x plus 40 equals c, the distance between the island and point Q. From here, we then could answer Part A, finding the function. Since we know that the formula for finding distance was rate times time, we knew we could find time by dividing distance over rate. Since we have two distances with two different rates, we would have to add two equations: the distance to point Q over the rate at which was being rowed, plus the distance to point R over the rate at which was being jogged. From there, we could immediately begin plugging in the numbers. The square root of x squared minus 12x plus 40, which is then divided by 4 miles per hour. We then added x miles divided by 6 miles per hour to get our function for tx. Our next task for Part B was to find the minimum amount of time it would take for you to reach the restaurant and how far we would need to row from the restaurant. We first need to find a graph, which is pictured here. We then need to locate the minimum point on the graph and the coordinates pictured here. Given the coordinates on the graph and the y-coordinate to be the amount of time it takes, we can figure that it takes at least 1.37 hours to reach the restaurant. Because we also know that the x-coordinate gives the distance, we can figure that you would need to row 4.21 miles, from the restaurant. Next is Part C, asking us to find how long it would take to jog half a mile. Given that x is distance and t is time, we inserted 1/2 as x. We plugged the new x into the equation, and t of 1/2 came out to be 1.5464, and it would take 1.5 hours to jog half a mile. Thanks for watching.